Welcome everyone to the event, Making Smart Contracts Really Smart, Building AI-enabled Financial DApps. So before I hand over to Bianca, our moderator today, to start the event, I would like to make a quick introduction about the event logistics. As this event is going to be big, everyone is going to be muted except for the speakers. If you have any question or suggestion during the talk, you can scan the QR code to join our WhatsApp group and discuss in this WhatsApp group, and you can also stay in touch after the event. That is from my side. I hope you enjoy the event today. And Bianca, do you want to make a quick introduction?
Thanks a lot. So today you will hear two presentations about today's topic. And in the beginning, I want to introduce you to our speakers today. Our first speaker is Philipp Brune. He's the founder of QWICS Enterprise Systems and the co-founder of and CTO of QWICS Solutions, as well as a professor for business information systems engineering at the Neu-Ulm University of Applied Sciences. And our second speaker for today is Tobias Leicher, a set client architect at IBM. Thank you for joining us today, and I will hand over to Philipp Brune for the first presentation.
Yes, thanks a lot for the kind introduction, Bianca. We are heading for the first presentation. The idea today is to make it more interactive and more fun for all of you. Of course, is that we will not talk too long, but we will then move on to a discussion. And of course, we're looking forward also to your questions and your input. So please let me share my screen and move on to my presentation. So I hope everyone can see the screen, and just checking the chat. Yes, so welcome to our topic today, smart contracts, or how to make smart contracts really smart. And with really smart, of course, if we talk about smart today, we typically talk about machine learning and AI and analytical systems and so on. And our topic here is, can we use AI in the context of smart contracts? And before we do that, let us just briefly have a recap what actually smart contracts are. Because I think sometimes smart contracts are, of course, discussed as a part of the blockchain, but actually it is interesting to see that the idea of a smart contract is already older than probably at least the blockchain in its form today. Smart contracts have been suggested already in the 90s, a long time ago, by Nick Szabo, who is a computer scientist, and he's also, maybe some people know that he also wrote some other papers that were kind of anticipating cryptocurrencies and so on. So he's still considered by some, maybe he is the person behind the Satoshi Nakamoto, but that's still, of course, not clear. So Nick Szabo in the 90s wrote an article, which is cited here, and there he introduced the concepts of a smart contract. And the smart contract is something that combines the protocols and user interfaces to formalize and secure relationships over computer networks. Objectives and principles for the design of these systems are derived from legal principles, economic theory, and theories of reliable and secure protocols. So the idea of a smart contract is something that actually is used to transform a legal contract, a classical paper-written legal contract, into an online or automated digital form, in that sense that it can automatically ensure that the contract is kept and using appropriate protocols for that. So a smart contract is in principle something that turns a contract between humans into code. So if you consider a contract between two parties, it typically is something that says, okay, if I do that, then you do that. Okay, so it's basically a sequence of kind of if then else or if then conditions. And so it's obvious that you can somehow translate that into a program. So A smart contract is the implementation of such a protocol between two parties or more than two parties by code. For that, you need a Turing-complete language. That's a programming language that is actually a general purpose programming language. And yeah, then you can basically turn every contract into some kind of code. So this is actually implemented today in the famous or well-known blockchain frameworks. For example, on Ethereum, we have the Solidity language and the Ethereum virtual machine to implement such smart contracts. So smart contracts have evolved a little bit beyond this original notion of just being a contract. This is more what we would use in crypto assets or things like that. But you can understand them today as kind of a way of a distributed, immutable piece of code that can actually be kind of the basis for all kinds of business operation. This is what we also as a company do, so or use. So I will come back to that in a few slides. Something that has somehow got lost in the last years in the discussion is the second thing that Sabo originally wrote, namely the term user interfaces. So originally it had the idea that this contract must have kind of a user interface. Today, the user interfaces are still not really comfortable, and this is also a point that we as a company and also in my project QWICS have been or is addressed. So there was a nice article in the ACM transactions just not too long ago, in 2019, which actually discussed, of course, the limits of blockchain-based implementations. And well, there was this nice headline which I wanted to share with you: the infeasibility of a smart Obama-Trump contract. What is meant by an Obama-Trump contract is it is kind of a ironic formulation addressing this issue that Donald Trump said he will release his tax declaration if Obama makes public his birth certificate. And the idea is, in that sense, that this is a kind of a contract where both sides of the duties have to happen in real world, and this is something that will not work on a blockchain. Because, or at least it's not made for the blockchain, because in principle, at least one side of a bilateral contract should be executable on the blockchain itself to make it secure. That is the idea. But of course, in financial services, this criterion is usually fulfilled, and smart contracts are beneficial there, and they are usually beneficial when the execution of some kind of contract or contract-like scenario is either consumes significant time in a classical paper-based way, or effort, or is in general creating a lot of overhead. So that every time you can save time and therefore money by automating the execution, you can benefit from smart contracts. And that is actually what, just as a brief remark, what we as a company do with our product SQustody, which targets at simplifying asset management processes, so B2B processes using blockchain as kind of a distributed business application processing platform that integrates classical legacy systems. I will not go into much detail here because this is not the topic of today, but you can just take the message that we are working on a solution that actually is capable of building more complex and also AI-enabled business applications for, let's say, automating business processes. So our SQustody product is based on QWICSchain, which is a prototypical blockchain implementation originally emerged from a research activity of mine as a professor. And so it is also published. So if you're interested, you can read the paper and read more there about the details, the technical details. This image is basically just illustrating, okay, if you think of a blockchain, you always have the situation here you have these different nodes or these different parties involved. And technically, this would mean every party has a copy of this solution and they are interacting with each other, exchanging data. And we are using this QWICSchain platform. The advantage of that is what you can see here is that it is written in, let's say, in enterprise technologies, relational databases, Java EE, and Spring Boot, and so on. And now let me come to the actual point of making these things smart. Okay, so what could be meant by smart? First of all, one question is the question about the user interface, and the second thing is about actually the AI part. Okay, so if you let us just have a brief look on the picture or your opinions about actually the quality of today's smart contracts. I have a small kind of mini survey for you, which I would like to share. And so please, everyone, please go to Slido. I hope you can see that, and you then enter this code. So it's.
If I quickly would steal you the sharing, then anyone can see also the results.
Yes.
Give me a second. There we go. Now you can also scan it, by the way, with your mobile phones if you like.
Right.
Shall we start with the first question, Philip, or was there?
It was only one question that I sent, so it's
the one that you sent.
Yeah, the fourth one.
There.
Exactly. So, yeah. You only get one result.
So far, yes.
So far, maybe. Now we get more.
Let people give. There are just 3 people. There we go. Now people start joining. Oh, there's still a bit change. Good.
Numbers are going up. Great.
Guess we slowly.
Yeah, I think we reached the limit. But I think the picture is clear. So what we can see here is, the majority, or at least 50%, are not using them at all. And at least 18% are really thinking it's too complex. And at least a reasonable number is using them, and also maybe considering it's tedious, but still using it. So I think what one can see here is clearly that the adoption of, thanks Toby for sharing, the adoption of smart contracts is still not really very, very big. And I think that's something that we also consider or think so. And this is why we developed our platform to improve these things. Okay. So first of all, regarding smart or really smart, I think an important point is to have better user interfaces. User interfaces that make smart contracts also usable. If you think about classical business applications, the users are typically don't have to know what's going on behind, and even though there is the possibility to do programming, it's not necessarily necessary. There's a lot of customization that you can do without programming to adjust kind of standard software or COTS software to your needs as a company. And this is something that we would like to bring to the world of smart contracts by using a template-based language that is part of our smart contract engine, and which allows then to create a lot of complex variants of contracts using just a friendly user interface with clicking and no programming. Okay, but that is one asset that our product offers, and the other is, of course, and that is the topic of today mainly, the use of AI. So we are heading for using artificial intelligence as part of a smart contract. So this means that a smart contract is able to make decisions based on trained AI models. So in a general workflow, this could look like this. And this is the implementation of the technology, which is also published in this white paper that you can see here on the right-hand side. And as a language for the smart contracts, QWICSchain is using Groovy. And this uses basically trained models that are handed to or put on the blockchain as a JSON structure calculated by the PFA library, and then can be used inside the smart contract. So the idea is that the blockchain implementation itself is not mainly there for, well, not there for training the model, but for using the models, okay, for the inference phase. And the actual training is done offline with the actual data, so that then the model can be deployed as part of a smart contract. So that is the technology, and this allows to process transactions on the blockchain that actually could make decisions based on artificial or machine learning based models. So can be different algorithms. This is a kind of generic format that actually allows to exchange trained models and embed them on the blockchain. So technically, you can see here the library which is used currently, and the stack that we use. But I think we can also discuss that in the discussion. But for the interesting side, this is actually the way how we think that AI could be brought onto the blockchain to be beneficial, to really be used in distributed applications or in smart contracts. Another aspect, and this is what now I will just hand over to Tobias Leicher here, is the question or the point that we are strongly evaluating the use of the IBM Linux One Service for running these kind of blockchain implementations, because it has also the AI implementations, because it has some unique features that would be, I think, very beneficial for, let's say, business-to-business high-end blockchain enterprise use cases in the context of financial services. And this is basically through the performance, through especially through the new features, the upcoming features that are just around the corner now, which will allow to run AI models in hardware very, very quickly and optimize the use of these AI models. And another thing, of course, is the Java performance, which is also exceptional, which is something that is, especially for a Java EE-based application as ours, is extremely helpful. Okay, so but I will not bore you with these things. It's just to mention that this is an interesting alternative that we explore, and that we also would love to share our experiences with other companies, startups, and of course are also willing to help you with that. Okay, so thanks a lot for this introduction, for the time, and now I hand over to Tobias Leicher, who will kind of continue with that, and then we will have also a kind of a discussion afterwards.
Thank you, Philip. Yes, I realized after 1.5 years at home, still sometimes miss to unmute myself. So I'm not sure. We had a previous session on here before, so I thought maybe asking a question. Did you join our previous webcast? So it's basically the same Slido. If you still have it open, the question now changed, and you should see the question bar. Good. Oh, we have plenty of people that haven't joined. That's also good. So I will make some notes of maybe has been said already in the last webcast. 3. That's okay. So if we have a lot of people that say no here, and I would quickly allow you another question to answer. Have you ever heard of this IBM Z Linux One thing that Philip just mentioned before in the last chart and that you have seen? Also a bunch of no's, even some yeses, some not sure's. That's very good. The not sure's especially come handy when you use some public cloud service that you may haven't noticed so far that you use an IBM Z machine. So that's very good. Thank you very much. Good. Then I would switch to the presentation. And you see one of these Z boxes over here. Philip showed you one where it had some orange stripes on here. I have the blue ones. Basically, they are the same. The only difference is the orange ones are made for Linux only, so they just look a little bit different. And so my topic here is to show you how IBM systems and generally systems can make a difference. And just a little bit of disclaimers up front. Everything I talk about now is not really public as of yet. It's not been generally available. You can't actually sue me for that. And there are some trademarks that you should notice. And now I come to the actual presentation. So this bit is just a little recap. When you have been with us last time, you may have seen this bit, this picture before. Basically, this is how an IBM Z machine looks inside. And there are two things that are very special. One is the integrated HSM. So you basically have the chance to have an own key management within the machine. And this HSM is a little bit special because it, for example, allows you, if you actually try to steal it physically, it will destroy itself. And so it is a very, very secure thing. So that's cool bit on there. And then we have another cool bit that is on the chip, actually, that is on-chip cryptography. And this is what we talked about last time. So maybe if you Google our last sessions, maybe you can rewatch it. There were some more details on that. And that is already there today. So nothing secret here. But now when we go to the next chart, and I also added some links to the hot chip presentation that a colleague of mine from the US did. Let's just imagine what we could do if we had more AI capabilities on a processor, more than we have today with the classical pattern. So classically, our CPUs can, of course, do anything. They are multi-purpose. So they can calculate a lot of things, but they are not really made for this. It's the same for crypto. As you've seen before, we did something special for crypto on the processor chip. So now just imagine we would do the same thing with AI. What could you do? You could actually do real-time business insights, because if the infuse of the AI is really, really fast, you could do it in business transactions. Because at the moment, if you, for example, think about it, you would put it to a GPU cluster, for example, you have round trip times and stuff like that. It doesn't seem long, but if you imagine you would do it for stuff like getting money from the ATM and stuff, it is a little more hard, because if you add another second to it, then stuff will queue up. It will be very complicated. Same is true for operational stuff. So if you just think about doing operational AI and actually think about your IT with AI technology. Oops, I pulled down my chair. Sorry for that. You would also need some more performance to actually do that. And what IBM did is basically we introduced at Hot Chip a new chip design. It's called the IBM Telum chip. You can also Google it. That bit is public knowledge. And you will find also these little charts over here. Basically, it's a 7-nanometer chip. And before I do that, I have a little question, I remember. And let you do some guessing. Quickly share the question. How many transistors would you expect on a modern chip? If you did read very fast, you may already read the number. We can now check if you've been that far. It's been raised. See lots of people participating. That's good. If you haven't been there before, you can basically scan this or go to slido.com and type in these numbers. Then you can quickly join our little quiz here. let's wait a second. And I quickly change the sharing again. So maybe some of you have read it already, or you even know, which is even better. The number is actually over 22 billion transistors. So on this chip, and this chip is basically just as big as a usual chip, there's a 7 nanometer technology, which is very funny. When I started in computing, basically people said, oh yeah, and then there's 14 nanometers, and then that's it. You can't go smaller because then you have so many side effects by the transistors and the electrons. You can't go smaller. Now we are with 7 nanometers, and just half a year ago, I think there was also some research papers about a 2 nanometer technology. So even when you think there is nothing more to do, there's even more to do. And this new chip has some special stuff, and we will go through that very shortly. So some bits are about the memory. So basically it has a lot of level 2 caches that are directly beside the processing cores, and that can also act as a virtual level 3 and level 4 cache. That's actually quite interesting concept because most computers, you know, will just have a level 3 cache, and the level 4 cache is also shared between different of these processors running in the same system. As you may know, the mainframe systems, they can actually scale to very big systems, and then you have a lot of these cores that can also share each other's memory and have a direct access from each core to memory of other cores, which is quite phenomenal when it comes to performance, because that really allows you a very, very good performance. And that is what I want to focus on. We added some accelerators. I talked about crypto a little bit before. Today, I want to talk a little bit about what we try to do with AI. And as I said, this is not a chip that you can use today. It's actually some fresh off the press. I think the hot chips announcement have been a few weeks back. Same is true for security and reliability and availability. So we can even live with broken level 2 cache, level 2 caches, and of course broken main memory, because we actually make some calculations to even recover from that and do error correction on it. So not just break and come back, really actually let the business software that runs on it not even notice that something broke. So when we think about this accelerator, basically we have this bit on this chip that is actually, let's say, a little facility that every one of these processing cores can use. And you see there are 8 processing cores on this chip. There are also other things, as I said, the crypto stuff, but also this AI accelerator. And that's very interesting to use, because if you make it available to all the processing cores without actually using processing powers, so you can make it very distinct to the functionality that you want to use. You want to use, for example, vector calculations and stuff like that. And you don't have to use your normal processing power for it, because normal processors are very good for general purpose stuff, but they are not really perfectly done for the AI calculations that you usually would do. That's why we use a lot of GPUs for it, because GPUs are very good at vector multiplications and stuff like that. And the idea now was, what if we bring it close to the processing core to actually make it work very, very fast, because we are talking about a quite significant rate, I think something about 100 gigabits in a second, that can actually flow from the caches of the processing core to the AI accelerator, which then means that your inferences can actually be very much in the time frame of a few nanoseconds, which is very, very good. So this will actually help you. And also one cool thing is, even though we actually ship that chip at one point in time, it works with a lot of firmware in it, so you can actually enhance it afterwards and actually can make it more powerful in the process while it is already delivered to you on a customer side or in the cloud and someone is using it. So this is really great. Also, one thing that is very interesting, if you think about you want to do AI on the chip, it is much harder to actually get into the requests than if you would ship it from one box to the other. So also from a security perspective, this is actually quite a helpful thing. You see basically, just as an example from one core, that you can basically go there. There's a new hardware instruction that is used for that. So the Z chips generally are QWISC architectures. So there's a new memory-to-memory QWISC instruction that you can use from the chip, from your program, to actually make use of it, which of course is not very interesting to many people, especially business developers, because they will not write assembler. So what we need, of course, is a usability version of it within the upper level software that we actually make use on it. And this is pretty cool. As I said, it has straight access to the memory, and it has different facilities that actually do the prefetching to it. So the AI accelerator really can focus on the AI stuff that it wants to do. And you see here, matrix multiplication is a thing, vector multiplication is a thing. Activation function, quite also an important area that we see in lots of AI uses these days. And to make just a little view on this AI accelerator itself, we see there are lots of arrays that actually do the array multiplication. We have lots of speed to actually do that. We have over 200 teraflops of capacity that we can do on it, and we have lots of integration with the actual memory, which makes it very, very fast. And that's actually the cool bit about it. I don't want to go into too many details actually. Just let me say this. The idea was, and that was also something that Philip mentioned, that you can train it anywhere you like. And the only important thing is that you want to do your actually AI execution. That is the things you want to run with your business stuff itself. You don't want to run like training in live, but you want to, when you execute, for example, your smart contract, you want it to be very, very fast, because if your smart contract then will take a lot of time, your business application will not feel very comfortable with it. So you want to make sure that the models you actually trained, that you can deploy it to a machine that actually can execute it very fast. And you see over here, there's a software stack. And basically the idea is, of course, that if you want to use it in, for example, an application that runs Java, an application that runs Python, C++, or even COBOL, you basically can just call this functionality within the normal software or in the normal programming that you would use. You would not actually call an assembler macro to do some matrix multiplications. You would have a very easy interface to actually make stuff work. So you can, of course, use also TensorFlow, but you can also use this ONNX to basically do a compile on this hardware architecture, because of course this accelerator is a very special thing. You need to have it dedicated to the hardware from a software perspective. So that works well. And with that, I just have some more information about it, because as you might can tell, I'm not the developer of it, but we have the developer talking about it. So when you go ibm.biz/telum-blog, you get the blog entry of the hardware developer, -news, you get the news entry of the announcement. And if you go telum-video, this is probably the most interesting one. It's a 20-minute of the chip lead architect that actually explains the stuff that I just showed you in short, in a little more depth, and maybe it's more interesting to those people who are really interested in hardware design and how it is actually done. So I think the cool thing here is that we do with hardware something that we can make use from a business perspective. And that is very interesting, because especially AI is a very complex computational thing from the computer science guys' point of view. And so what we want to make it, what we want to make here is to make it easy to consume, but also make it perform very, very fast. So that, for example, when you think of stuff like fraud detection, or you have massive amount of smart contracts, you don't want to, if you have a smart contract that only runs once a day, doesn't really matter. But if you have a really running system where you have like 1,000 contracts a second, you don't want to wait for your AI inference every other second, because you have to ship to another system, or you actually have to run it on a normal CPU, which makes it very, very slow. So that's my points here. Thanks a lot. And now we go over to the questions phase, I think, and hope you have interesting questions to roast us.
Thank you both. So I would get into it here. The first question we want to ask you is, how could a smart contract as a blockchain solution be connected with artificial intelligence?
All right, maybe I answer on that, but I think you have seen a little bit in the slides as well. So in general, I think there are different settings in which you could use, or in which smart contracts and blockchain and AI could be combined. Okay, so there are basically two settings. One is to use blockchain for doing kind of a distributed computation in a way that you, for example, there are scenarios where maybe don't want to share the data between parties, but you want to train a model. So this is more for the training phase. This is more, I would say, research experimental stuff that you could think about using distributed computation for training. What we do is actually using AI for inference. So on the blockchain, so making use of pre-trained models on the blockchain, and this is probably more the business relevant case. There actually the AI is used to make better decisions, for example. So if you have a transaction processing system, regardless if it's a centralized system or a decentralized system, usually the transactions will involve some business logic, business rules, and this could, of course, involve also making more smarter decisions. So this is what we had in the title today, and the smarter decisions could be achieved by making use of AI operations, and this then based on the data, for example, of the transaction. And this is what actually Toby explained, that this hardware would allow us to accelerate that, because it does it actually in hardware. And with the software stack that our SQustody is using, we can make use of this platform and also of the acceleration, and we make AI run really as part of a smart contract on the blockchain. And I think that is the more relevant perspective from a business point of view, because let's say that the training of the models, of course, is something that you usually do not in real time. It's done beforehand and offline. Of course, this might change in the future as well, but for the moment, this is probably the more interesting case.
So maybe also a business example. I mean, depending on what you do with your blockchain and where you want to use smart contracts, maybe you will invent another currency. There, of course, the same problems apply that you would have with credit cards today, for example. If you want to, for example, spend at one point in time a few Bitcoins from Australia, and at the next point in time you want to spend it from Russia, you can, of course, write some code to do this questioning, or you basically train your contract to actually detect stuff like that. So from a business perspective, there are basically no limits, and everything you can do via normal programming, or a lot of things you can do via normal programming, you can also do by detecting
Anonymous.
anomalies, things that are not really great, but in your workflows. Sorry for that.
Thanks a lot for your answer. So I would like to continue with the first audience question, which is kind of related to the further question. Do you store the AI model inside the smart contract on the blockchain?
Yes, we do that. Because the model must be part of the smart contract to be sure that all the parties do the same or achieve the same result from the computation, and it must be immutable as well as a code, as the chain code itself, because it's part of the chain code. It's not directly program code, but it's part of the chain code, and therefore it must be recognized that it's changed. So that is stored on the blockchain. Yes.
And what kind of decisions do the AI models deal with?
Well, in general, I think, of course, as I said, a smart contract is a Turing complete language, and AI models are also generic. So you can, in principle, do all kinds of decisions. I think that in the beginning, probably kind of intelligent. So Toby gave the example of fraud detection, which is also something that is implemented in classical transaction processing systems today, but kind of as on top, so addressed on top. But so fraud detection could be something, but of course the number of use cases in principle is unlimited. Yeah, so any kind of, for example, automated detection of things could be also, for example, a kind of detecting voice or images or things like that. But of course, one must always say, okay, is it worth to put it on the chain, or is it better to process it in front before you put something on the chain? And then, of course, it's not so relevant. But I think everything related to actual transactions is something that could be implemented on the chain.
Right. Thank you. And the third question would be, did you specify the use of the smart contracts?
Actually, I don't understand the question. What is meant by specify?
With the
I think it's the same question as before, probably. Could that be? In the sense that is the use limited to some certain cases, or?
So maybe just add another question to that, because I'm also not sure what it meant. And I mean, specific to what you can also, I mean, you could have a blockchain that has all the Stradivari's in the world, and of course it is very easy to detect or use an AI model to check, has there recently been someone that actually sold one, or is it maybe a fraud? So there are use cases that you probably wouldn't think of.
So maybe the author of the question could specify it a little bit more, and then we can answer it. In the meantime, there was a question in the WhatsApp chat, which was, do we need blockchain in order to implement smart contracts? Which was already answered by not necessarily in the WhatsApp chat. So what's your opinion on that?
I think it's clear that the blockchain, the smart contract idea is older than the blockchain, or it also came up independently of the blockchain. What makes it, so in principle, you could, of course, implement kind of a contract mechanism in a centralized way, so that you have a trusted party that is responsible for executing the contract, like a notary, for example, in the classical paper world. But I think then the question is if it's really useful then, or what are the use cases. I think the real interesting thing comes up with the additional feature of blockchain, that this contract is transparent and immutable to everyone, so that everyone can rely that the contract is actually the same, and that everyone adheres to the contract, because it's not possible to manipulate it. And that, I think, so the question is, yes, in principle, smart contracts are not bound with the blockchain, but I think there's a reason that they became popular and together with the blockchain in recent years, because in this scenario, it makes actually more sense, I would say.
Thank you. We just got another question on the WhatsApp chat. I'm just reading it from my phone. What barriers do you see, if any, in broader acceptance and usage of smart contracts? Any headwinds?
Well, I think the main reason we had the short survey, and I think the main reason today is still that it's a very complicated thing that actually is not just a technical solution, but it also has to do with legal aspects and of course aspects of existing social structures and infrastructures, like we have banks, we have a stock exchange, and so on. So in the financial service world, everything is regulated, and you have a very strict system, and you have established processes, at least in the Western world, I would say, so, or in the developed countries. So the question, of course, is in principle, a smart contract could do anything, and you could implement, from a theoretical perspective, you could implement basically every transaction as on the blockchain. So this would make many institutions not necessary anymore. And of course, this is not something that, the question is, do you want it? And of course, what would be the societal change and so on? And it might not even just not be worth the effort, because we have a working system. So in general, I would say blockchain and also smart contracts are at the moment limited to certain use cases where they actually make sense and where they can really bring an improvement. That's such as the asset management process that we are proposing, SQustody. But in general, there are certain use cases, and I think that the adoption is, the reason for the adoption is, first of all, of course, the technical weaknesses, as we outlined, the let's say bad usability, the complexity, the new technology, the lack of developers, and so on and so on. And on the other hand, of course, the question that in many cases it might just not be necessary for a certain scenario. So I think the blockchain has a great potential, but it has to be applied to the right scenarios. And of course, it has to become more business ready as it is today. And this is what we as a company try to work on.
Thank you. So now we have a quite long question or message with it. So it says, I get the basic idea of AI usage, the enhanced usage of SE, so smart contracts. My concern is rather about transparency to transport the whatever logic behind smart contracts, particularly if enhanced by AI to the end user. SC itself need to be made understood by the user, even more AI supported. Your thoughts about it?
Okay, my concern around about transparency.
Maybe I have a start then, Philip. Yeah, I think
Yeah.
you hit a very good point. So generally, smart contracts, of course, need to be understood by every party, because otherwise, I mean, if someone cheats on you and you didn't notice, it's probably even your own fault. So you're of course very right that people that want to make use of it have to understand it. And that's also another interesting question on who is the user. So basically, am I, as Toby Leicher, who sits somewhere in the world, really a user of this blockchain, or am I just using services that are made secure by this certain smart contract? And of course, if you want to understand it, you need to have a certain amount of skill. And maybe just adding to this, and I would leave the rest to Philip, but adding to this AI bit, I think that's a very crucial one for generally everything we do in AI. So AI has a very ethical part, an ethical question. If I don't understand what the AI does, so same applies to, for example, autonomous cars. If I don't understand what it does, who is actually responsible for it? Can I make someone responsible for an AI algorithm that I just trained and by accident trained, for example, with the wrong data? So this is actually a very interesting research topic that we have lots of research also in IBM, where people look at how can we make an ethical AI? What would we need to do so? So you may remember that IBM stopped a few years ago face recognition for one of the reasons basically was that we said we are not very happy with the unethical behavior of some face recognition, because with a lot of the training data we have, we look at the data, it is very much middle-aged men, white people-ish that we get, and the result, of course, is not very happy and not very nice in certain bits. And you all maybe can imagine that this can happen, and that the results can be embarrassing. So the question of an ethical AI is very, very much crucial, and it's a question that we all need to understand, because the code that we generate with a neural network, for example, is not provable anymore by theoretical informatics, for example. So we can't really make sure that it is actually behaving rightful. And that is why we need to also find ways on how to control it, how to make sure that the AI is not doing something strange, for example, because someone trained it badly. So you may also remember that Microsoft had an AI a few years ago, and after 10 minutes being open to the world, it was just swearing and become very racist and stuff like that. So of course, AIs have a potential to be exploited. And so we need to make sure that this is not actually happening.
But regarding the blockchain, I think that with this approach, there was just a question: do we actually deploy the AI model on the chain? Yes, we do, and it is then immutable. And what also comes with the blockchain naturally is it is transparent to all the parties. So I would say that an AI model deployed in a smart contract is even better than an AI model from an ethical perspective, than an AI model that is implemented somewhere by a provider that hides it from you, like Google or Amazon, where you just call a service and get a result, but you don't know the model and you don't know how it would behave in certain cases. In our case, the model is, of course, it is in numerical form, so it's not easy to understand, but it is documented and it is immutable and it's on the chain. So if it behaves wrong and it is recognized, everyone can say, okay, we have to change it, and then you can ensure that it is changed and so on. So it is the blockchain keeps kind of a proof of the model. So I think from that point, it's even better, or an improvement compared to a centralized approach. So I would say AI on the chain is to that respect, regardless of all the things that Toby mentioned, that the model can be ill-trained and behave badly, but on the blockchain you at least have the chance to see if it is improved and also to see what the model actually is made of, and so that I think is an advantage compared to a centralized approach, even in that sense.
Thank you too. And the next question here would be, what would be the future vision of AI in smart contracts? What would be a real-life example for companies?
Well, I think, for example, you could think of scenarios of AI-based automated trading on the chain. That could be something so if you think about financial services, and of course you have these kind of robo things that automatically make decisions for investment or things, or reaction on operations on the chain. And this could be, for example, something that could be used to even be implemented on the chain itself to trigger, for example, some transactions or some things automatically. That could be a real-time example. So that the question is if this is always good, but I mean, automated rule-based trading is used for a long time. We had it already in the 90s and 80s with the big crash and so on. So these are techniques that are used. And on the other hand, of course, the same could be used for automated, for example, risk management. If you do trading on the chain and you have a risk management that actually, for example, if you are able to predict or to see, okay, this might develop in a bad way, you could, for example, stop the transaction or have some limits or something like that. So I think these are use cases in financial services on the chain that might be implemented using AI on the chain.
Thank you. Another question would be, are there any limitations regarding running DApps on mainframe? Why should someone do so?
Yeah, other limitations. Whatever you can imagine is probably your limitation. There are, of course, some technical specialties. It's a special hardware. As I said before, if you want to use AI models, you want to compile them to the hardware and stuff like that. But what are advantages? I mean, additionally to just what I've mentioned before, when we think of what we talked about last time when we talked about the crypto stuff, especially when you have like blockchains that have a lot of crypto proving in it, for example. Not sure why someone wants to do that in this case, but if you do that, and if you have an unpermissioned database with an unpermissioned distributed ledger with a lot of crypto, that's, for example, a very good use case for the Z hardware, because we can do that crypto stuff in Accelerator, as we said today with the AI stuff. And generally, it is also interesting to ask where you want to use it. For example, if you are a financial institute and you want to make an alternative currency, you may already have the infrastructure for a lot of things on this machine running, and you may just add some bits to make the blockchain work. So this, for example, could be another reason why you want to run it on Z. And it's just a very powerful hardware. So like Philip said, when it comes to Java, we can do stuff like pause-less garbage collection. It's a very strange word, because in Germany, pause-less can also mean without any pause. So we are not garbage collecting all the time, but we can actually garbage collect without stop the world approaches in the JVM and stuff like that. So that's also interesting.
Yes, I think the reason to do these things on the mainframe is, or on the Linux One machine, is of course, if you look at the big financial service providers, the reason might be they have it already. Okay, so that's different. But if you are a startup and you're thinking about a platform, of course it depends on the use case. I mean, this hardware is extremely powerful, but of course it has a price that's clear. That is maybe higher than you just get the pure computing power from a other platform. So the question is what you get for the money, and we learned a lot about the technical advantages and also things. But of course, you must say that this also saves you money, because you don't have to deal with certain things like hardware acceleration, maintaining complex infrastructures. So it can be a use case or a business case from a total cost of ownership perspective, especially as a startup, because you can kind of move a lot of concerns and issues that you have, like security and also if you are in the financial services world, you have, of course, regulations, and you have customers that are extremely security aware, even if you are a fintech startup like we are. And for them, of course, it is definitely interesting to have a platform that kind of relieves you from a lot of, let's say, concerns about how do I manage my hardware security modules, and how do I implement encryption, and is cloud service for them acceptable or not, because might have a look inside or whatever. So all these things are basically solved by the hardware without any additional tag or price tag. Okay, so that's the big thing. And IBM has actually started to really try to get startups in this world from the fintech space mainly, of course, and they are doing also some kind of attractive offerings regarding pricing for startups, be it in the cloud or be it in for the physical machine. Of course, for startups in the beginning is typically you don't need the largest one. You can probably start with smaller machine or smaller configurations, and there are some attractive startup offerings as well. So I think that the price is the system is worth the price, the additional price tag it has. And it could save you money on other sides. And also, of course, some things are technically possible that are not possible on a standard Google, Amazon, whatever x86 hardware. So that is the main reason for a startup to think about running these, especially, let's say, mission critical enterprise blockchain things on such a machine.
Thank you. So maybe we will have one last question for also as a summary for today's meeting, which is, what are the main advantages of distributed apps?
Yeah, so I think that's a clear thing. That's the main advantage is that you can build up business processes between parties that don't need to trust each other and that don't need to trust some common third party. That's the idea of a blockchain, okay? And the distributed app is running on the blockchain. So if you have, let's say, different parties that are working together on something, a deal, a transaction, whatever, and they are kind of, they need to agree on the state of this ledger. So they need to agree, and in a traditional way, they might do it by bilateral negotiations. They might reconcile things and call each other all the time and fix things manually. You could have, for example, a network that actually does this automatically. Okay, so it just resolves the problem of parties agreeing on the state of a certain for example, ledger, set of bookings or whatever. So that is one thing, and you have to find use cases that actually fit to that pattern. I mean, that's the reason why so many blockchain things in the past have been more like, okay, let's do blockchain, but we don't know why we do it. So it's just because it's cool also. That is of course not useful, because if there is a central party in a business network, and the central party is somehow trusted, be it a big company with some smaller suppliers, or be it kind of a central bank for a bank, whatever. So there are many examples. I don't really see the need for a blockchain in such scenarios. So the need for a blockchain is there where you either don't have a central authority, or you don't want a central authority, or you want to get rid of the central authority. So that is the thing. And if you don't have it, and you can optimize the process, which might be built on kind of bilateral trust relationships so far, then you can get a business value from that. And that's the reason to use blockchain. And then, of course, it's a reason to use distributed applications on that blockchain to do your business process.
We just got a last-minute question via the WhatsApp chat. I'll just read it out.
Okay.
Do you see countries like China implementing central bank digital currency without utilizing blockchain as a threat to blockchain applications?
Well, I personally don't think that electronic currencies that are implemented by central banks are a typical blockchain use case, because there you have the central bank. So is it a threat to blockchain applications? Not. It might be a threat to some cryptocurrencies, but not to blockchain applications in general. We are talking here necessarily not about crypto. We can talk about any kind of thing that you want to agree upon. I think blockchain itself has its use case, regardless if there's a central bank cryptocurrency or not. In general, a central bank cryptocurrency is, to me, or also any kind of cryptocurrency that has a central authority, is to me is not really a cryptocurrency. I mean, this is more like a electronic payment system or something like that.
Yeah, and I think as you rightfully said, blockchains always make sense or make a lot of sense if you have a trust issue. And that maybe is a question that everyone on its own can answer, how much he trusts the Chinese government when it comes to something. And I think that may be also different in other parts of the world. So I think that is the question. And you can also ask this question to any other central bank. Maybe you don't trust any central bank because you think money should be very free. And then you would also agree that maybe also the ECB should have digital currency without controlling it. And so I think that is a big question when it comes to blockchain. Do I have a trust issue or not? If I trust or at least one party that has the control, I'm okay. If not, maybe cryptocurrencies could be a solution, even though you have an official solution for it. I mean, like Bitcoins did not exist in a world where we had an issue. I mean, there were, of course, the dollar, there were the euro, there were all of these things, but people said, nah, we need a currency that we can trust because it is not to be trusted because there's no one that controls it. So that is a question that everyone needs to answer for itself. And I think trust issues are there a lot in the world. So there will probably be, even though all central banks do digital currencies, there will be still a reason why people think, let's do something without them.
So thank you too a lot for your time today. And I just sent the contacts of Tobias Leicher and Philipp Brune in the chat. So if you have any further questions, please feel free to contact them and to ask whatever you want. So that's it for today. Thank you for your participation. And I would hand over once more to Alexandra. If you want to add anything, feel free. Thanks and have a great day.
Thanks a lot for participating.
Thank you for the wonderful sharing from all the speakers, and I hope to see you in our upcoming events. Goodbye.